Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Converting a secondary alcohol to an alkyl bromide requires a reagent that substitutes the OH group with Br without causing rearrangement or side reactions, and does so cleanly and efficiently. Moving on to the next step. Evaluate each reagent. HBr. Option A. HBr can convert alcohols to alkyl bromides via an SN1 or SN2 mechanism. For secondary alcohols, it works but can lead to rearrangements and gives lower yields, also requires harsh conditions or a catalyst. SOBr2. Option B. Thionyl bromide, SOBr2, reacts with alcohols to form an alkyl bromosulfite intermediate, which then undergoes displacement to give the alkyl bromide with release of SO2 and HBr as gaseous byproducts. This reaction proceeds cleanly, gives high yields, and the byproducts, SO2 and HBr gas, are easily removed, making the product pure. It is analogous to the well-known SOCl2 reaction for making alkyl chlorides. Br2, option C. Molecular bromine is used for addition to alkenes or electrophilic aromatic substitution, not for converting alcohols to alkyl bromides. CH3NGBr, option D. A Grignard reagent is a nucleophile base and would react with the alcohol's OH bond, proton transfer, not substitute the OH group. Moving on to the next step. Identify the best reagent. SOBr2 is the best reagent because it converts the alcohol to the alkyl bromide via a clean mechanism with gaseous byproducts, SO2 and HBr, giving a pure product in high yield without rearrangement issues. And for the final step. HBr can work but is less clean and may cause rearrangements with secondary alcohols. Br2 does not react with alcohols to give alkyl bromides under normal conditions. CH3NGBr simply deprotonates the alcohol. Therefore, the correct answer is B. Therefore, the correct answer is option B.